We are continuing work on topic 6.13, looking at improper integrals, and we're going to look at example 5 in this video. So in this one, we notice we've switched, and now we have both a negative and a positive infinity that we're going to and from. So I'm going to split that up into two separate integrals that I have a better chance of finding the limit or the integration of. And I get to pick any value I want. One of my most favorite convenient values is 0, so I'm actually going to split this in from negative infinity to 0 of e to the x over 1 plus e to the 2x dx, plus from 0 to infinity of e to the x over 1 plus e to the 2x dx. And please write tiny. You're going to probably need sticky notes. I apologize in advance for that. And it was e to the x, yeah, okay. So we're going to go ahead and put the limits in this, then I'm going to start writing it just a little differently. So we know we need to switch it to improper integrals, so limit as, and I'm going to go a for the lower one. So we're going to go from a to 0 of e to the x over 1 plus, and I'm going to rewrite this a little bit differently. It's the same as saying e to the x squared. And then plus the limit as b approaches infinity from 0 to b of e to the x over 1 plus e to the x squared dx. I forgot my dx here. Okay, hopefully you're noticing that this is like a and a u, so it's looking very arctangent. I'm going to do some u substitution. I'm going to put it on the left side here. So u has got to be equal to e to the x, which the good news is that means that du is equal to e to the x dx. So you'll notice how we have, there's the du right there hanging out, okay, in both of these. So I have everything that I need. I don't really need to add anything extra. So I am going to go ahead and just write out the u substitution piece. So we've got the limit as a approaches negative infinity from a to 0 of 1 over 1 plus u squared du. Technically, yes, we should change our limits. I'm going to choose not to because we're going to substitute the x's back in here in a minute. All right, plus the limit as b approaches infinity from 0 to b of 1 over 1 plus u squared du. Now, I could have even skipped that if I wanted to and just done just say, hey, this is an arctangent, and I'm going to go deal with it. So I know when I integrate, I'm going to get the arctangent. So we've got the limit as a approaches negative infinity of arctangent. So it's 1 over a, right? So it'd be 1 over 1, which I really don't need. Arctangent of u. Instead of writing u, I'm going to go ahead and substitute that in. So e to the x over 1 plus the limit as b approaches infinity of 1 over 1 arctangent of the u, which we know is e to the x, plus, so over 1, and then from 0 to b. So now let's go ahead and substitute all of that in. So I have I should have written it from here from a to 0. Okay, so now we've got it equals the limit as a approaches negative infinity of arctangent of 0 minus arctangent of a plus the limit as b approaches infinity of arctangent of b minus arctangent of 0. All right, well, we know that the arctangent of 0 has to be where, I'm looking at my notes, sorry. The arctangent of 0. Okay, so the arctangent of 0 has to be where sine and cosine are both 0, right? So we know that, or sorry, not sine and cosine, where it's equals cosine over cosine equals 0. So I know that that's at 0 radians, just like we saw earlier in the lesson. So I know that this has to be 0 and this has to be 0, so they both go away. Now I am going to, and I don't know where I missed something, didn't I? Right in here I missed, this should be e to the a. I know what else I missed. Totally messed up this line, I apologize. Okay, so this should have been e to the 0. This should have been arctangent of e to the 0, which is why my notes weren't looking like they should have. E to the b. Okay, let's rethink that. So we know that we need to know where e to the 0, anything to the 0 power is 1. So we need to know where arctangent is equal to 1. Well, we know that happens when we have square root of 2 over 2, square root of 2 over 2, which happens at pi over 4. So I know that we have the limit as a approaches infinity of pi over 4 minus the arctangent of e to the a plus the limit as b approaches infinity of arctangent of e to the b minus pi over 4. All right, I'm going to go ahead and plug in my, actually this is a negative infinity, and in my positive infinity. So I'm going to move my work over here. So we've got pi over 4 minus arctangent of e to the negative infinity plus the limit, is not the limit, we're getting rid of the limits, plus the arctangent of e to the infinity minus pi over 4. And the pi over 4's cancel. They're basically insignificant. And then we know that this one here is the same thing as saying negative arctangent of 1 over e to the infinity. And then we know that e to the infinity would just be infinity. This piece here we would know would be 0 because 1 over a giant number is 0. We learned earlier that arctangent of infinity is pi over 2, so therefore this converges.